Now let's look at this question. Let x to be a random variable with probability mass function px given in the table below. So this table is a typical representation of probability mass function. So the first row will give for all the possible value of random variable x. For this particular case, x can get value 1, 2, 3, 4, 5. And the second row, the probability of x when x equals to 1 is 0.5, when x equals to 2 is 0.2, and so on. So this is how we interpret this particular PMF table. And the PMF table sometimes can also be visualized in a graph format for easier for us to understand. So let's first do that before we try to proceed for this problem. So we know that for x equals to 1, the value is 0.5. For x equals to 2, the value is 0.2. For x equal to 3, the value is 0.1. And for x equals to 4 and 5, the value is 0.1, 0.1. And let's first verify whether this is a valid PMF. For valid PMF, we need to fulfill first that for all the value of x, the probability must always be non-negative. So we see based on this particular graph, we will see that for all the possible value of x, it is always greater or equals to 0. Okay, so we fulfill the first criteria. And then we also know that in order for a PMF to be valid, for all the possible value of x, the sum of probability of x must equals to 1. So let's check whether this is also valid. So let's see 0.5 plus 0.2 plus 0.1 plus 0.1 is equals to 1. Hence, this is also verified. Hence, it is a valid PMF for random variable x. Okay, now let's try to solve. For part A, provide the cumulative distribution function fx. For CDF, normally is denoted as capital letter F. So let's see. For this question, is basically test your understanding about the definition of CDF if x is equals to the probability of random variable x less or equals to x. That's the definition of the CDF. So now you see, if we want to, we have already know for each value of the x, what is the probability based on this PMF table and PMF graph. We just need to list down, convert this one from x equals to a particular value, 1, for example, convert it to x less or equals to a particular value, let's say 1. Okay, maybe this is not a good example. Let's try continue first. So first we will see that because we have 5 distinct points, so this is divided into 6 ranges, and fx is regarding ranges. So we first discuss about the first range. Fx equals to the first range basically is before value reach 1. So basically it's x less than 1. The probability will be 0 because for x less than 1, there's no valid value that can be chosen from x because x can only get value 1, 2, 3, 4, 5. So that's why the probability of f x less than 1 is 0. So we will see for x greater than 1 but less than 2. So basically is from here to here but exclude the value 2. So this basically is the only valid value of x in this range is x equal to 1. So this is equivalent to f1. And based on the definition, we'll see it is equals to x less than equal to 1. Basically is equal to x equals to 1. And from the graph or from the table, we know that it's equals to 0.5. So here is 0.5. Then the next range will be x less than 3 and x greater equals to 2. So similarly, for this particular range, the earning value for x is x equals to 2, which is equivalent to the probability of x less or equal to 2. So we can say that the probability of x equals to 1 plus the probability of x equals to 2 basically is nothing but the sum of these two bars here. So here is 0.7. So similarly, we can get x less than 4, x greater than 3, x less than 5, x greater than 4. And don't forget the last range here. Basically is x greater or equal to 5. So correspondingly, because each bar is 0.1, so for each step, we increase from 0.8, 0.9 to 1. So all this is corresponding to F3, F4, and F5. Okay, so for here, I will not calculate each individual one of them. You can just based on what I described, based on the definition of fx and the two examples I given below, you will be able to get the value at least down here. Okay, now let's look at part 2. For part 2, basically is to draw the graph of fx. We have already got the formula for fx. We just need to draw it out. So this I would say that is relatively straightforward. So let's first get x, and then we get fx here. So for x less than 1, the probability is 0. So basically is here the probability is 0. And for the probability of the second scenario, the probability of x less than 2 and greater or equal to 1, the probability is 0.5. 0.5. And because here there's no equal sign here, it is only talk about the x value that cannot reach 2. So here we use a circle to represent the value 2 is excluded. And then similarly, we can get the next value, which is 0.7, which is equivalent to, which the range of the value for x is from 2 to 3. So similarly, we exclude 3. And then the next 0.8, 0.9, and 1. So similarly, we can get here, exclude 4, and here, 0.9, exclude 5. And then we will get from 5 to infinity is equals to 1. So basically, this is the graph representation of CDF of x. So this is the CDF for fx. Okay. So this question basically is to test your understanding first, your understanding of the probability mass function PMF for discrete random variable, and test your understanding on how to convert from a PMF to CDF. So that's all for this question. Thank you very much.